In this lesson, we are now starting our stats concepts and going back to measures of central tendency. So like mean, median, mode, range, box and whisker plots. However, I'm going to show you guys now, we're going to introduce in this video how you can use technology when calculating these pieces. And we're going to also introduce to you guys a new concept. And this new concept is what is called the standard deviation of data. So the standard deviation is the square root of the variance, and we're going to use this symbol here. We're going to use sigma. So sigma is going to always represent the standard deviation. So what you guys need to understand about standard deviation is this. If it is a small value, then it's going to be, the data is going to be very clustered, very close together, near the measure of the center. So versus here, it's going to be a larger value, the standard deviation, if the data is more spread out away from the center of the data. So now when we're talking about these calculations, like for example, mean. Now, mean was the average, right? Mean was the average, and you would take your data, you would add up all the numbers, and then divide by how many numbers there were in the data. Well, in Desmos, but the scientific calculator, you can calculate in the scientific calculator, it can do that for you, the mean and standard deviation. So just to show you guys, and I'll go back to that, you click on the function button, and here it is right here, mean and standard deviation. So like you would click on mean, and then you would put in the numbers. That's it. So you would put in the numbers. So like I'll just put in like 7, and you have to separate them too. So 7, comma, 8, 9, 10, 11, 12. Why not? And then close the parentheses. And then there it is. So here, the mean or the average is 9.5. So same thing. If you wanted the standard deviation, you would go to function, standard deviation. Same thing. You would put in those numbers, 7, 8, 9, 10, 11, 12, close the parentheses, and your standard deviation is 1.87. Now, this is a very small number because if you notice, the data is very close together, like it's not very spread out. So that's why here, that's what I mean by you have a smaller value versus if the numbers were more spread, then you would have a larger standard deviation value. So now to show you in the graphing calculator. Now in the video, I'm going to focus more on the graphing calculator. And that's because the Desmos Scientific really only does mean and standard deviation. I'm going to show you guys how now the graphing calculator, truly no matter what version you have of the graphing calculator, we're going to follow the same steps and it's going to give you more data, and you're going to see that in the first example. But these are the steps that we're going to use. So make sure if you have the notes or print them out, that you're following along. So we're going to click on the stat button, edit button. I'm going to go through these steps and show you guys. But it's going to end up showing you a screen like this on your calculator. And then here, so notice it's going to give you a lot more data points. So like in this first example, we're going to use this data of these 12 packages to find the mean, the median, the mode, the range, the standard deviation. So remember, right, mean is your average. Now, mean in the calculator, you're going to see this symbol, which is the X with the bar over it. So keep in mind that is your mean. Then the standard deviation, remember that is your sigma, or you could also see it with like the sigma X in the calculator. So here now I'm going to show you with a graphing calculator. Oops, sorry about that. Let me get out of this so you can see. So we're going to go back to the beginning. Stat button right here next to on the second row. So you're going to click on the stat button and this is going to pop up. See how it's already highlighted edit? Then you're going to press enter to edit. Now make sure you're in line 1. And now you just start putting in each number. You put each number and press enter. So 6, enter, see? So 4, 3, 4, 2, 5, 3, 4, 5, 2, 3, and 4. And then notice there's our 12 values because it's asking for the 13th. Now that you've got your data in, we're going to go back to that stat button. So you're going to click on stat again, but not edit because we already edited. So now you're going to arrow over. So click on that arrow over to calculate. And here, just the one variable stat. So again, it's already been highlighted. So we're going to enter. See how it says the L1? That's why you need to make sure you're in that list 1. Then you just press enter until you calculate. And here's all your data points. So you can arrow down and there's the rest. So here we go. The first point, X bar, you see that X with the bar over it? That is your mean. So the mean is 3.75. Now, then the median, well, if you arrow down, here it is, MED. Median is 4, the middle value when you list them from least to greatest. Now the mode, the calculator is not going to give you the mode. You just have to look for the value or the number that occurs the most. So I see 4s, 1, 2, 3, 4 of them. I see multiple 5s. 1, 2, well, that's only 2 of them. 2s, 1, 2, no, only 2 of them. 3s, 1, 2, 3, nope. So it looks like our mode is 4 because that's the value that occurs the most. Then the range is always the spread of the overall data. So that's always the maximum minus the minimum. Now in this case, I can clearly see that the maximum value is 6. So 6 minus the minimum, which is 2. 6 minus 2 is 4. So that is your range. Now, I could also go to the calculator. Let's just say, well, what was the maximum? Maximum right here. Maximum is 6. What was the minimum? Min, 2. 6 minus 2 is 4. So the calculator also will identify for you if maybe you end up, let's say, with a larger data set, the maximum and the minimum value. Now we're going to look for the standard deviation. Now the common mistake is people see the S and go, oh, there's my standard deviation. We actually do not need ever this SX value or this sigma X squared, the sigma. We're never going to use that. Remember, standard deviation is that sigma. So that's what you need to look for. So sigma X right here, 1.164. So 1.164. That is a standard deviation. So make sure to look for that sigma. So go ahead and pause the video and try this on your own. Try these steps on your calculator. And if you don't have access to a graphing calculator, what I can do is, and I can also provide to the other teachers, this website, because this is actually not a software. This is actually free access to a graphing calculator. So what I can do is I'll put the link in eClass, and I can also send this to the other teachers so they can put this on their eClass page as well. So go ahead, though, and pause the video and try this. You try here on your own. And here we go. So let's make sure you got this. Now, I realize too, and if you need to go back and repause this, some people might be like, how am I supposed to get out of this screen, or how do I delete the data? So you could just clear it, guys, to go out, or you can see how it's quit. So you second quit, or you could just click on the stat button. So go back to stat. We're going to edit and see how it still has all these numbers, because we need to delete all this. So you just press the delete, don't press clear. You need to press the delete button to delete the numbers. So now if you need to repause the video because you weren't sure how to do that, then go ahead and do that here and now try this on your own. And here we go. So now again, right, we go to stat, edit, so enter, and then here's our list one. So 14, you should have had 10 numbers here. So now here we go. So again, you were supposed to then click on stat button again. So click on the stat button, but then not edit, right? We need to arrow over to calculate. Then there's your one variable. So enter and just enter until it shows you. Boom. Here we go. So the mean was 10. That's your X with the bar over it. So here the mean was 10. The median, so go back, the median, so arrow down, boom, here it is. Median was 11. That's the middle value when you put the numbers in order from least to greatest. The mode, now that's the value that occurs the most. Now I see 11 has been repeated. Are there any other values? Nope. So 11 was the mode. Then the range. So again, the range is always the maximum minus the minimum. Now you could have used a calculator to identify the maximum, right? The maximum value is 16. The minimum value is 3. You could also see that visually here too, that the largest was 16 and the smallest was 3, making your range 13. Then the standard deviation or the sigma, right? So sigma is right here, 4.025. So 4.025. And that is your standard deviation. Notice how here, this one is a larger standard deviation because the spread is larger. Notice how the range is 13 versus this answer is smaller because the range, the spread was only 4. So now we're going to practice again using the graphing calculator, but to create and look at what we would use as our box and whisker plot. So a box and whisker plot is just another way of showing the spread of the data set. And we're only going to focus on 5 key points here. So notice how we just need the minimum, the maximum, the median. Now, this is something new. The first quartile, or Q1, right? Quartile 1. That is going to be the median or middle number of the lower half of the data set. Then quartile 3, the third quartile, is the median, the middle number of the upper half. So notice it goes in that order. You have your minimum and maximum at the end, right? So minimum, then the first quartile, then the median of the overall data set, right? The middle number. Notice how quartile 3 is in the upper half now, the middle number, followed by your maximum. Now, this is also something new that we're going to introduce. Interquartile range, or you'll see me use IQR. So that's just shorthand for interquartile range. So that is the range between the quartiles. If you think about it, right? Inter between, so quartiles. So we are going to take the range, not the maximum and minimum, the interquartile range. So we're going to subtract that quartile 1 and 3. So if you notice the quartile 1 to quartile 3, this spread will always represent the middle half or 50% of the data. So here we're going to do the same thing. To get the values of the box and whisker plot, you just put the values in the calculator, just like what we did before. So go ahead and pause the video and do that part on your own. Let's make sure that you remember those steps. And here we go. So let's make sure and let's see if you remembered. So on the calculator, go to stat and then already edit. So enter, and here's your values. Now you should have put in a total of, if I'm not mistaken, 16 values. So now we're going to go back to stat and then go over to calculate and then enter. And here we go. So we need the minimum, maximum, quartiles, and the median. So if you notice by arrowing down, all of that information is actually the last 5 pieces in the list. The minimum is 11. Quartile 1 was 13. The median is 14. Quartile 3 was 18. And the maximum is 23. And that's it. So notice the calculator, you just go to those last 5 key points are actually listed for you in the calculator. So if I wanted to create, so then that's just here at the value 11, 13, 14. So here, 15, 17, so 18, 21, 23. So here I've got my points. And then remember, here you have the whiskers at the end because the box is what is your quartiles, which is half of the data set. And then here, that line through to show your median. And this is your box and whisker plot. So notice again, that's your 5 points. Now, if I wanted to know what was the interquartile range, then remember, we just need quartiles. Well, what was quartile 3? 18 minus what was quartile 1? 13. So 18 minus 13, the interquartile range is 5 versus the overall range would be the maximum minus the minimum value, right? That's the overall spread, which is 12. So the interquartile range is 5. So go ahead now and pause the video and get these 5 points, key points, and create the box and whisker plot and get the interquartile range for this data set on your own. And here we go. So let's make sure you put this in correctly. So again, you're supposed to go to stat, then just edit, so enter. Then here's your list. You should have had about 9 if I'm not mistaken. So now go back to stat, but then arrow over to calculate, enter, and just press enter until you get to the calculate. Then remember, right, the 5 parts, so the 5 pieces that we need are the last 5 data points here. So the minimum was 4. So minimum was 4. Then you need the quartile 1, you need the median, you need quartile 3, and you need the maximum value. So quartile 1 is 5.5. The median was 7. Quartile 3, 8.5. And then the maximum is 10. So now here, minimum 4, then 5.5, then 7, then 8.5, and 10. So now notice, creating our points, you have your whiskers at the end with the box in between, and to show the median, drawing your line in between. There's your box and whisker. Now, the interquartile range, the IQR. Again, you were supposed to subtract the quartiles. So that is 8.5, quartile 3, minus quartile 1, 5.5, giving you an interquartile range of 3. And so now the last concept here that we're going to be talking about is the outlier. So an outlier is an extreme value that is much less than or much greater than the data values. And it could have a strong effect on the mean and standard deviation, meaning it could affect how high or how low the mean or standard deviation are, whether you take it out or not. So the outlier is that extreme value, but sometimes it could be hard to tell. So that's why to find the outlier, we're going to calculate. So here, the pieces of information that we are going to need to identify the outlier of a data set. We need the quartile 1 because we need IQR, which means we also need quartile 3. So the lower bottom cutoff, we're going to use this piece here. So if any number is below that bottom cutoff, when we calculate quartile 1 minus 1.5 times IQR, or if there's any number above this upper cutoff here, then that will be your outlier. So go ahead, pause the video, and put these 15, let's go ahead and calculate. So go ahead and get the information in your calculator and put this in on your own. And here we go. So again, remember, right? Click on stat. It's already at edit, enter. Then here's all your values and make sure you should have had 15. Then you go to stat, but then arrow over to calculate and then enter until it calculates for you. And here's your information. So here's what we're going to do, because we're going to identify not only the outlier, but how it affects the mean and standard deviation. So let's go ahead and identify the mean. So if you remember, what was the mean? The X bar. Good. So the mean here is 92.77. So the mean is 92.77. And the standard deviation, let's see if you remember, what was the standard deviation? Right here, not the S, right? The sigma. So 0.195. Let's round that because of the 8. So sigma, our standard deviation was, I already forgot, 0.195. There we go, 0.195. Now we're going to figure out what is the outlier. But remember, we need quartile 1 and 3 to identify what is the IQR. So quartile 1 right here, 92.7. Then quartile 3, so arrow down to get to the Q3, 92.9. So that means when you subtract these two values, the IQR is 0.2. So now here's how we're going to calculate. Here, my suggestion is no matter what, the key value is 1.5. That is what you multiply the IQR, right? No matter what, you are multiplying 1.5 to the IQR, the interquartile range. So to get the lower, we're going to always take quartile 1 and subtract. If you think about it, right? We're always subtracting and then taking that value, the 1.5 times the IQR. Then to get the upper, we're going to take quartile 3 and we're going to add because that is the upper. Then the same value, right? So let's go ahead and calculate. What is 1.5 times the IQR, which in this case was 0.2? You should have gotten 0.3. So this is the value that we're going to subtract from quartile 1, which was 92.7 minus 0.3. And then we're going to add to quartile 3, which was 92.9 plus the 0.3. So here, the cutoff value is 92.4. Then here, the cutoff is 93.2. So now we're looking for any value that is outside of this. Is there anything below or is there anything above? Well, I noticed all of our values when we put them in were 92 point something. So we don't have anything above. But do we have any values below 92.4 outside of this? Yes, 92.1. So here, our value is 92.1. That is the outlier. So now we're going to go through and see how does that outlier affect the mean, median, I'm sorry, not the mean, median, the mean and standard deviation. So we already calculated the width, which was 92.77 and 0.195. So now we're going to redo our data and but take out 92.1. Now, don't delete the whole thing, right? And then put in 14 values. So here, guys, go to the calculator. Oop, we're going to go back to the calculator, go back to stat, and again, edit, right? Because we need to edit the list. Arrow down until you get to and find the 92.1, the outlier in your list. There it is. And only delete that one value. That's all you need to do. Don't delete the whole thing, right? And then re-put 14. Just find the outlier, delete that. Now we can go back and click on stat. So stat, then calculate and enter. And here we go. So now the mean is 92.82. So the mean is 92.82, because remember, right, that's your X with the bar over it. And then now what is the standard deviation? 0.077. So 0.077, because that was your sigma. So now notice, how did this outlier affect? Well, our mean, what happened to our mean? Without the outlier, our mean increased. And then what happened to our standard deviation? Well, here, our standard deviation decreased, which makes sense now because it's going to get smaller because now the spread of the data is not as large as it was before. So the standard deviation decreased because now our data is much more close together versus with the outlier, it was a little bit more of a spread. So go ahead now and pause the video and try this on your own. So try to identify, right, what is the outlier here. So you're gonna have to put the data in and see how it affects the mean and standard deviation. And here we go. So I'm gonna say with the outlier and without the outlier, right? Because we're gonna need the mean and standard deviation for both. But we also, no matter what, have to figure out, right? Well, what pieces of information did you need to figure out the outlier? You just need the quartile 1 and quartile 3, because that's the pieces of information that you're going to need to figure out the IQR. Then remember, what is that key value that you multiply by IQR? Well, you multiply that by 1.5. So here we go. So again, stat, then you were supposed to enter, and then there's your list. Then you click on list, calculate, and then enter here. And here's your information that you should have gotten. So the the mean with the, so the X bar. So you should have gotten 4.86. And then the standard deviation, you should have put 2.875. So here, 2.875. So remember, this is with the outlier. Now we got to figure out what the outlier is. So here, quartile 1 was 3, quartile 3 is 6. So 3 and 6, which means the interquartile range is 3, right? From 6 minus 3. Then that means now you had to multiply, right? 1.5 by the IQR, which was 3, making this value 4.5. So now remember, right, to calculate, you need the quartile 1, but we're going to subtract, right, because that's the lower. You're going to subtract from that the 4.5 value. Then here, remember the upper quartile, that means you're going to add to that the value that we calculated here, which was the 4.5. So here we go. You have quartile 1, which is 3 minus 4.5, which gives you negative 1.5. Then here, quartile 3, that is 6 plus 4.5, excuse me, which is 10.5. So now this is the in-between range that is good to go. Well, it doesn't make sense that we're going to have any negative values, right? So below, so we don't need to really look at that. But are there any values? Did you notice anything that is above 10.5? Yes, 12. 12, what was the outlier? 12 is above 10.5. So 12 was the outlier. So now you should have, when you did the without, take out the 12 and see what is the information now without the outlier. And so now here, making sure, right, you go back to the list, so stat and edit, and just delete the outlier. Now we go back and recalculate. So arrow over to calculate, enter, and here we go. The mean is 4.31 because we're going to round that up, right? So 4.31, and the standard deviation is now what? 2.162. So 2.162. So notice what happened when we took the outlier out. Without the outlier, both the mean and standard deviation went down and decreased.